Okay, we have here to kind of a messy looking integral from the Caltech Math Meet 2025. And the trouble with it is it looks like it's set up for a u substitution and a trig substitution. For the u substitution, now like if this right here, we can look at this as e to the x all squared. If that was our u, then we have our du right there. So we can definitely do something with that, but then the result is going to require a trig substitution. So you could actually combine it all into one. I'm not going to do that. I think maybe it's clearer if we do it one at a time. So we can set up a u substitution for just e to the x. But you know what? Because 4 is a perfect square, I think it's going to help us out if we do this a little different. So instead of doing it this way, we can write this expression as 2 times e to the x all squared. And then we'll make this thing our u. So then u is going to be 2 e to the x. Take a derivative and we get 2 e to the x dx. So let's just manipulate this a little bit. I'll take the minus sign out here, multiply in a 2, multiply by 1/2, so I'm not changing it, right? So this is still just a minus sign. That way this with this is going to be altogether the du. Go ahead and substitute. We got minus 1/2. Now this becomes square root u squared minus 9. Everything else is just du. And now for this is probably different ways, but let's do a trig substitution. Let's do the hyperbolic trig substitution on it. I think it's going to work pretty nice. If I do, we'll do u, setting that equal to cosh of t. That's going to be pretty nice, but we want to get the 9. 9 is 3 squared. So if we do 3 cosh t, then u squared is going to be the same thing as 9 cosh squared t. Let's take a derivative on this. We're going to have du equal to 3 sinh of t dt. We'll do a little more to set this up. What we can do is solve for t, divide off 3, invert it, and we have t equals inverse cosh now of u divided by 3. And then another thing that's going to be useful is the identity that we have for the hyperbolic cosine and sine. If we have cosh squared minus sinh squared, this is just equal to 1. Rearranging this, we have cosh squared x minus 1 equals sinh squared of x. We're going to use the second one here, so let me get rid of this, and then we'll go ahead with this substitution here. So we have minus 1/2. This becomes this value, so yeah, let's write it out. So we'll have 9 cosh squared t minus 9, and then du is going to be all this stuff, 3 sinh dt. Okay, now let's try to do a quick cleanup. I can factor a 9 out of this, so then this becomes cosh squared t minus 1. With the 9 factored out inside the radical, we bring it out front and we have a 3 here. But now we can use the identity on this. This is the same thing as sinh squared of t inside the radical. So for the whole thing, we're really going to have the square root of sinh squared of t, which is going to be absolute value sinh of t. Now for the absolute value here, sinh is always positive when t is positive. It's always negative when t is negative. But look at our definition of t over here. Inverse cosh is always greater than 0. I'm not sure, maybe I guess greater than or equal to 0. But anyway, this thing is never going to be negative, so we can actually just drop the absolute value right here and we can clean up our integral. So we'll bring the constants out front. 3 times 3, 9 times this is going to be minus 9 over 2. This is sinh of t and this is sinh of t, so we end up with sinh squared of t. And then on this thing here, we can use the power reduction, really similar to the power reduction on sine, just it has a different sign on it. So it's going to be minus 1/2 plus 1/2 cosh of 2t. But then let me use the minus sign here just to reverse the sign on this. We'll do this and reverse it over here. And then we just clean up the board. We'll continue with this integral right here and finish it off. Okay, now from here, let's go ahead and integrate. We've got our 9/2 in front. Then integrating here, we have minus 1/2. This is going to become sinh 2t over 2. I'm not going to combine it because what we can do is use the identity on this right here Sinh of 2t is the same thing as 2 sinh t cosh t. And then what I can do is cancel 2's right here. That way we have it in terms of just single angle, so we can use the definitions we have to the right. Now cleaning it up, we'll factor a half out of both these, so we have 9/4. Let's go and start back substituting. We have to get it all the way back to x, but for t, we have this right here, so it's gonna be cosh inverse u over 3. And then here, cosh t, we already have a value. Basically, we just need to divide by 3, so cosh t is u over 3. What about sinh of t? Well, for sinh of t, I deleted the identity we had before, but for sinh of t, we had square root cosh squared t. This is when we removed the absolute value. So we had this thing, but we know cosh t is u over 3. So then, let's see if I have enough space here. Plugging u over 3 in here, it's going to be u squared over 9 minus 1. And now we just need to get everything back to x. We have our definition for u, so we can just kind of plug into that. So we'll have 9/4. Here, this is going to become cosh inverse. Plug that in, we have 2/3 e to the x. Here, I'll reorder this and bring the u over here just because it makes more sense over there. So we'll have 2/3 e to the x square root. Then this thing is going to become 4 e to the 2x over 9 minus 1. Now from here, I think what I want to do is, let's actually distribute the 9/4 back in. If I distribute it on the cosh inverse, we can just kind of remove this right here. Then here, if I multiply 9/4 times 2/3, I can write this over here as 3/2. But then if I just bring the 3 inside the radical, I can clean this up. Because if I bring it inside, it's going to be a 9, so I can cancel it with that. Make this a 9 right here. And then at this point, we've got a good solution here, but what I want to do is clean it up or just get it into the form that they have it. So the definition for cosh inverse, let's just look at that and we can use it to transform this piece. What we can do is use this formula here, putting it back into natural log, where the input, the x, is going to be all this stuff right here. So we'll use this definition here to transform what we have. And then here, just notice that this radical, we can do basically the same thing we did on this one, get these two to look the same. But here we don't really have anything in front to multiply in, so I can just factor a 1/3 out of this and rewrite it. So let me do this carefully and write it out for my final solution on this. We have 9/4 natural log 2/3 e to the x. Here, factoring the 1/3 out, we have 1/3 4 e to the 2x minus 1 minus e to the x. Oh wait, I need a parenthesis right there. Over 2 square root 4 e to the 2x minus 9. Add a plus c, and that's it. Okay, so hopefully what I have here matches what's in the answer key. Personally, I think what I would do is take a 1/3 out, because you could turn it into a constant that would get absorbed here. But I think what we have here is going to match their answer key. So we'll go with this and call it good. Thanks everyone for watching. Have a good day.